This conference will now be recorded.
Good morning, students. In today's class, we are going to solve a few problems on steady state errors. See, in last class, we started on problem, right? So we will continue in this class. So this is the problem we discussed in yesterday. Already we found that first question, that is different static error coefficients. Now we are going to be start that second one, that is steady state error if input is r of t is equals to 2 plus 4t plus t square by 2. So first of all, here I am going to write that the given parameters. So g of s equals to 20 divided by s into 1 plus 4s 1 plus s. And what is the h of s value here? What is the h of s value? For this given problem, what is the value of h of s? So for this problem, the value of h of s is 1. Okay. So what is the question here? To find out the steady state error if input. Okay. So the steady state error formula is ESS is equals to limit s tends to 0 s into E of s. So this is the formula for steady state error. And if you substitute E of s here, then you will get limit s tends to 0 s into R of s divided by 1 plus g of s into h of s. So this is the formula. But the given problem, in the given problem, the input is given in time domain. So R of t is equals to 2 plus 4t plus t square by 2. Now you have to apply the Laplace transform to this equation, then you will get R of s. What is the value? What you get R of s here? For first one, first if you apply the Laplace transform to the 2, what you will get here? If we apply the Laplace transform to the 2, what you will get? Two by s plus second time if you apply the Laplace use of 4t, then you will get 4 by t square. Sorry, 4 by s square plus if you apply this Laplace of 2 square by 2, then you will get 1 by 2s cube. So this is the this is the input value in S term, 2 by S plus 4 by S square plus 1 by S cube. Let me see this. Right. So here 2 will get cancelled. So this is the R of S value 2 by S plus 4 by S square plus 1 by S cubed. Okay now if you substitute this R of S here, then see that what you will get. Limit S tends to 0, S into R of S divided by 1 plus G of S H of S. So I am going to be substitute R of S here, that S into 2 by S plus 4 by S square plus 1 by S cubed. So if you substitute limit S tends to 0, so here the denominator we have the S term, right? So 20 divided by G integer is infinity, that is 1 plus infinity. So let me see that what will. So limit S tends to 0, S into 2 by S plus 4 by S square plus 1 by S cubed divided by 1 plus 20 divided by S into 1 plus 4S one plus S. So if you see this value, then the numerator you will have. So prati term nunchi 1 by S common cheyandi, then you will get limit S tends to 0. If you take that 1 by S is common, then you will get 2 plus 4 by S square plus 4 by S. This is 1 by S square. So so ఇక్కడ నుంచి 1 by S కామన్ తీసాను, 1 by S cancel అవుతుంది, then you will get it this divided by 1 plus 20 divided by S into 1 plus 4S into 1 by S. Now if you substitute S is equals to 0 in this term, 2 plus 4 by 0. 4 by 0 is infinity and 1 by 0 also infinity. So 2 plus infinity divided by 1 plus. So entire term you will get infinity. This is the steady state error value for the given input. Okay na? So ఇక్కడ గుర్తుపెట్టుకోండి, 1 plus infinity is also value of infinity. So ఈ విధంగా వస్తుంది. Okay na? So this is the first problem. Next you will see the second one. So the control system having the unity feedback has G of S 50 into S plus Y S square. Determine the static error coefficients. Find the value of coefficients. So that is Kp, Kv, Ka. So first of all, note down that what are the given values. G of S is equals to 50 into S plus 5 divided by S square, and H of S is 1. What is the Kp value? So find out the Kp, Kv and Ka. So the Kp formula is limit S tends to 0, G of S into H of S. Find the Kp value, and Kv value is limit S tends to 0, S into G of S into H of S. Next, Ka value. Limit s tends to 0, s square g of s into h of s. Find the value of these three values compounding. What is the value of Kp and Kv and Ka? Right. Kp is infinity. Then Kv and Ka. So Kv also infinity. Right. 250. So this is the answer for these three constants. So let me see that how we got these values. So if you see the first one, limit s tends to 0, g of s is 50 into s plus 5 divided by s square into 1. So ఇక్కడ s plus 0 ఉంది కాబట్టి anything by 0 is infinity. So the Kp value is infinity. And if you take that Kv, so here s term will be s plus get cancelled. So denominator of s ఉంటుంది. If you substitute s by 0, then anything by 0 is also infinity. And third one, so if you apply this acceleration error constant, s square get cancelled, then you will get 50 into 0 plus 5. So 50 into 5 is 250. So this is the values of error constant for the given open loop transfer function having the unity feedback. Right. So this is the Kp value, Kv value, and Ke. So this is the third one. The control system having g of s is equals to 20 divided by s into s square plus 2s plus 1, and h of s is equals to 10 divided by s plus 4. Determine the static error coefficient and steady state error. So let me do this problem. Given g of s equals to 20 divided by s into s square plus 2s plus 5, and h of s equals to 10 divided by s plus 4. Yeah, so these are the two as given. The first question is we have to be find the static error coefficient. The first one is Kp, positional error coefficient. Kp formula is limit s tends to 0, g of s into h of s. Now just substitute this g of s, h of s here. Limit s tends to 0, g of s is 20 divided by s into s square plus 2s plus 5 into 10 divided by s plus 4. What is the value of Kp here? So what will get here? Kp. infinity, because the denominator is multiplied with s, right? So entire denominator will get 0, so its value is infinity. We can find that second value, that is kV value. So the formula for kV is limit s tends to 0, s into g of s h of s. Limit s tends to 0, s into 20 divided by s into s square plus 2s plus 5 into 10 divided by s plus 4. దీనికి ఏం వాల్యూ వస్తుంది? Find the value for this. Zero. Is it right? So let's see. Here s get cancelled. Okay, now then we have the remaining term. If you substitute s equals to 0 in remaining term, 20 divided by, so s square 0, 2s is also 0, then you will have only 5 into 10 divided by s plus 4. So 0 plus 4 is 4. 5 ones are 5 4s are 4 get cancelled, then your answer is 10. This is the value of kV. ఎందుకు ఇక్కడ kV కాన్స్టెంట్ వాల్యూ వచ్చిందంటే, if you having this, if you see this is the type 1 system. So type 1 is type 0 system అయితే step input కి so kp వాల్యూ కాన్స్టెంట్ అవుతుంది. type 1 system కి kV కాన్స్టెంట్ అవుతుంది. type 2 వచ్చేసి ka కాన్స్టెంట్ అవుతుంది. So this transfer function look like a type 1 system. So that's why the kV value is constant. You got this answer? 10. Right. We'll see that third one, Ka. So Ka is equals to limit s tends to 0, s square g of s h of s. So what will get value for this? దీనికి ఆన్సర్ ఏమొస్తుంది? Right, super. 0, because yes, 1s cancel అయితే remaining ఒక s ఉంటుంది. So anything 0 into anything is 0. So the value of Ka is 0. So let me check our answer. So kV is, we got infinity. kV is 10 and K is 0. Right. So this is the way of for solving that. One more thing, this is the last topic from the second unit. So ఈ క్లాస్ తో సెకండ్ యూనిట్ కంప్లీట్ అవుతుంది. ఓకేనా? సో మీకు ఈవినింగ్ కొన్ని ప్రాబ్లమ్స్ ఇస్తాను. సో ఆ ప్రాబ్లమ్ ప్రాక్టీస్ చేసుకోండి ఈ రోజు, రేపు, ఎల్లుండి. ఓకేనా? సో ఫ్రమ్ మండే ఆన్వర్డ్స్ యూ విల్ స్టార్ట్ దట్ థర్డ్ యూనిట్. So let me solve that next problem. So second one is limit s tends to 0. So we have to find that steady state error, right? So we have to find steady state error. Let me see this. G of s equals to 20 divided by s into s square plus 2s plus 5, and h of s is 10 divided by s plus 4, and r of t is 5 plus 10t plus t square by 2. If we apply the Laplace transform, you will get r of s is equals to 5 by s plus 10 by s square plus 1 by s cubed. Actually, దీని లాప్లాస్ చేస్తే 2 by 2s cube వస్తుంది. 2 cancel, then you will get 1 by s cube. Okay, na? So the steady state error formula is ESS is equals to limit s tends to 0 s into r of s is 5 by s plus 10 by s square plus 1 by s cubed. Divided by 1 plus g of s value is 20 divided by s into s square plus 2s plus 5 into 10 divided by s plus 4. Now we have to be simplify this formula. So let me see that how we can simplify. Right. See here, if you this is the value we get here. So if you substitute s term is 0, okay na? So all will get that one any value by some value by 0. So numerator and denominator. So anything with 0 is it will get infinity, right? So if you simplify this all this equation, finally you'll get that infinity. So this is the value of the steady state error for the given problem. Okay, na? So this is the way of finding that steady state error constants and the steady state error. Next. So this is the second one. Let me see this problem. So దీనికి steady state error కోసం find out చేయండి. KP, KV and KA value for this transfer function. Find the steady state error coefficient for this problem. KP, KV and KA value. What is the KP value? KV and KA. right? Infinity, infinity, and 2.5. Very good. Okay. So I think you are all clear about the steady state error constants, right? Now we'll see that second one, steady state error. So first of all, I'm going to write that given parameters we have g of s is equals to 21 plus s divided by s square plus, sorry, s square into 2 plus s into 4 plus s. Right. And h of s is equals to 1. R of t is equals to 40 plus 2t plus 5t square. If we apply the Laplace transform to this, then you will get R of s is equals to 40 by s plus 2 by s square plus 10 by s cubed. Then find the steady state error E of s value, ESS value. ఏమొస్తుంది చూడండి ఒకసారి. So ESS formula is limit s tends to 0 s into 40 by s plus 2 by s square plus 10 by s cube. Divided by 1 plus g of s is 21 plus s divided by s square 2 plus s 2 plus s four plus s. Then find the value of k ESS. So first take 1 by s common is from this numerator. So చేస్తే మనకు 40 plus 2 by s plus 40 by s square వస్తుంది. డినామినేటర్ లో వస్తుంది చూడండి ఒకసారి. సో ఫైనల్ గా మీకు ఆన్సర్ 4 వస్తుంది. Have you all got this answer? So your answer is 4. So let me see that how it will get 4. Okay, now such choose and last. సో జస్ట్ ఐఎమ్ గోయింగ్ టు బి సింప్లిఫై. సో డైరెక్ట్ గా ఇచ్చే ఆన్సర్ మీకు సింప్లిఫై చేసి చూపిస్తాం ఎలా వస్తుంది. ESS లిమిట్ S tends to 0. ఇప్పుడు ఈ న్యూమరేటర్ నుంచి 1/s కామన్ తీయండి. 1/s కామన్ తీస్తే S క్యాన్సిల్ అవుతుంది. దెన్ యూ విల్ గెట్ 40 ప్లస్ 2/s ప్లస్ 10/s square. డివైడెడ్ బై, సో ఇక్కడ కామన్ చేయండి, s square into 2 plus s 4 plus s then plus 20 into 1 plus s. Whole divided by s square 2 plus s 4 plus s. You know, so next I am going to simplify this again. So if you the numerator term, if you take that common term, denominator s square, limit s tends to 0. So numerator లో denominator s square కామన్ తీసుకుంటే 40s square plus 2s plus 10 divided by s square 2 plus s 4 plus s plus 20 into 1 plus s divided by s square 2 plus s 4 plus s. సో ఇక్కడ s square క్యాన్సిల్ అవుతుంది. దెన్ సబ్స్టిట్యూట్ s is equals to 0 here. సో 0 చేస్తే ఇక్కడ న్యూమరేటర్ టర్మ్ లో 10 ఒకటి ఉంటుంది. 10 డివైడెడ్ బై, ఇక్కడ చూస్తే సో దిస్ ఎంటైర్ టర్మ్ will become 0 plus 20 into 1 plus 0. So 20 will get 20 divided by 2 4 the 8. So for 2 in the right, 2 and 2 plus 0 into 4 plus 0, 8. So you'll get 10 into 8 by 20. 10 ones are 10 twos are 2 ones are 2 fours are. So the answer is 4. సో ఈ విధంగా సింప్లిఫై చేయాలండి. ఓకేనా, డైరెక్ట్ గా మీరు 0 సబ్స్టిట్యూట్ చేయకూడదు. యూ హ్యావ్ టు బి సింప్లిఫైడ్. సింప్లిఫై చేస్తే మీకు ఆన్సర్ వస్తుంది. ఓకేనా, డైరెక్ట్ గా 0 చేస్తే సమ్ టైమ్స్ యూ విల్ గెట్ రాంగ్ ఆన్సర్. ఓకేనా, సో ఈ విధంగా సింప్లిఫై చేసి రండి, ఎందుకంటే ఇది 10 మార్క్స్ క్వశ్చన్. సో యూ నీడ్ టు బి indicate mention in the step form. That's then only you can get the full marks. So answer is 4. Let's see the next problem. So this is the last problem in this class. The control system having the unity feedback g of s is equals to 20 into s plus 1 divided by s into s plus 2 into s square plus 2s plus 2. Find the different static error coefficient and steady state error. So first kp, ka, kv value kanukondi. First find the error constants kp, kv and ka.